Hello everyone, welcome back. Today we're going to talk about element number 94, plutonium. Be aware, these elements that we have been discussing are radioactive. So please be mindful of this and others around you. Thank you. This information is for research purposes only, for the benefit of humanity. Let's learn about plutonium. It's an incredibly fortunate thing that making atomic bombs is so very difficult. If it were any easier, more groups would surely have done it by now. A uranium, element number 92 atomic bomb is hard to make because the uranium-235 isotope you need is extremely expensive to separate from the much larger amount of useless uranium-238 found in nature. Expensive as in, if you're not the government of an advanced nation, you can't afford it. But if you can get your hands on a critical mass of uranium-235, it's pretty easy to make a bomb. You essentially just build a cannon that shoots one subcritical lump of uranium into another. And boom. Making a plutonium bomb might seem easier because it is not so hard to get enough plutonium. Sure, you need a nuclear reactor, but that's child's play compared to isotope separation. In fact, at least one child has seriously tried. David Hahn constructed a breeder reactor as his Eagle Scout project in 1995 and got into big trouble when people realized it wasn't just a model. Some people think his miniature reactor might have actually worked. David Hahn, Scout. David Charles Hahn, sometimes called the radioactive Boy Scout or the nuclear Boy Scout, was an American nuclear radiation enthusiast who built a homemade neutron source at the age of 17. According to Wikipedia. But while it's relatively easy to get plutonium, through an incredibly fortunate coincidence, it's extremely difficult to turn it into a bomb. Plutonium splits so much more easily than uranium-235 that if you shoot two subcritical masses towards each other, they start reacting before they touch and blow themselves apart, before even a tiny fraction can fission. This is called a fissile. And while it might spread radiation over a wide area, it won't melt the target city as intended. To make a plutonium bomb work, you have to assemble the critical mass by imploding a sphere into itself using explosive lenses, which have to be nearly perfect. Any asymmetry in the shockwave gives the plutonium a way to sneak out the side. Even today, a plutonium fission bomb requires state-of-the-art metallurgy, pyrotechnics, and fabrication technology. Any amateur plutonium bomb would almost certainly fizzle. Plutonium is often called the most poisonous element. The people at Los Alamos is a census-designated place in Los Alamos County, New Mexico, United States, that is recognized as the development and creation place of the atomic bomb, the primary objective of the Manhattan Project by Los Alamos National Laboratory during World War II, according to Wikipedia. The people at Los Alamos, where nearly all of America's plutonium is kept, were so hurt by this that they published a paper defending plutonium against what they consider its unfair reputation. Well, they would do that, wouldn't they? So again, two plutonium cores would most likely fizzle. We are here on the periodic table. What is undisputed is that private ownership of plutonium is absolutely forbidden, with one tiny exception. Pacemakers today use lithium batteries, but a few people, no one knows exactly how many, still have models powered by plutonium thermoelectric batteries. If you have one in you, you're allowed to keep it until you die. According to the author, I have, and I swear this is true, gotten emails from undertakers asking me what to do with the radioactive pacemaker they found in one of their clients. Again, according to the author, as tempted as I might be to invite them to send me the plutonium for my collection, I have dutifully told each one that by law, all plutonium must go home to Los Alamos, where it will be loved and cared for. While plutonium is perhaps the most highly regulated and tracked of all the elements, the same is not true of all synthetic radioactive elements created in nuclear reactors. Take, for example, americium. If you're interested in learning about the element americium, I'll leave a link in the description below to learn about it. Let's continue with element number 94. Element number 94, plutonium. Chemical symbol, Pu. Nuclear bombs. Plutonium-239 is used in nuclear weapons with an explosive force equivalent to 20,000 tons of TNT, tinitro-toluene. Energy source. Plutonium has been used as a power source by NASA for the Voyager probes, the Curiosity rover, and more. Occurrence. It occurs in small amounts naturally. Most plutonium in the environment is from nuclear weapons testing. Homeopathic remedies are fraudulent products that contain none of their listed ingredients. In the case of these homeopathic plutonium pills, that is a distinctly good thing. Here we have plutonium nitricium. Here we have the outside view of a plutonium pacemaker. This plutonium pacemaker battery case is empty. Fortunately, if it were full, possession of it anywhere outside a body would be a crime. Plutonium. Focus on plutonium. Isotopes. Forms of plutonium are radioactive and produce heat. This is converted to electricity for various uses. Deep space probes, such as Voyager 1, use plutonium batteries as a source of power. Plutonium was used in early nuclear bombs. One such bomb was used on Japan in World War II. One form of plutonium is used as nuclear fuel for generating electricity. Plutonium, element number 94. Chemical symbol, Pu. The actinide plutonium was named after Pluto, the dwarf planet. It was the first artificial element to be manufactured in large amounts. It can be created from uranium in nuclear reactors. Its atomic mass is 244, its state is a solid, and its date of discovery was in 1940 by a team led by Glenn T. Seaborg. Fat Man, the nuclear bomb dropped over Nagasaki, Japan in 1945, contained about 14.3 pounds or 6.5 kilograms of plutonium fuel. Here we have a chunk of uranite, an ore of plutonium. Plutonium, element number 94. Chemical symbol, Pu. Much like uranium, plutonium is used as a nuclear fuel. Its most common application. Named after the dwarf planet Pluto, it was the first synthetic element that could be seen with the naked eye. It was discovered in 1940 in Berkeley, California, but its discovery was kept a secret until 1946, 6 years later. Because the Americans were concerned about national security and plutonium's use in a nuclear weapon. Here we have a glowing piece of plutonium oxide, the plutonium compound used as a nuclear fuel. Codename Fat Man. Nuclear weapons were dropped by the US on Japan toward the end of World War II. The plutonium-based Fat Man atomic bomb was dropped on the city of Nagasaki in August of 1945, just a few days after a uranium-based bomb was dropped on Hiroshima. So in Hiroshima, uranium was dropped, and in Nagasaki, plutonium was dropped. The devastating nuclear fission reaction that took place in Nagasaki involved plutonium atoms splitting apart to release huge amounts of energy. Here we have a replica of the Fat Man bomb, U.S. Air Force Museum, and National Aviation Hall. Here we have an artist's representation of the New Horizons spacecraft passing Pluto. Far from Earth. Launched in 2006 to study the dwarf planet Pluto, the New Horizons spacecraft carried about 22 pounds or 9.7 kilograms of radioactive plutonium, enough fuel to keep its instruments running for 10 years. New Horizons made its closest approach to Pluto in July of 2015. A quick review, here's the difference between a conventional chemical explosion, subcritical pieces of uranium-235 combined, and plutonium core being compressed, because plutonium requires compression for critical mass and uranium requires combination for critical mass. Uranium versus plutonium. Plutonium is dangerous. A small amount ingested in a human will result in death. This is not because it is radioactive. It's because it is a heavy metal, and heavy metals kill living tissues, such as lead. Plutonium is a very dangerous radiological hazard. Let's continue with element number 94, plutonium. Plutonium, element number 94. The actinoid elements. Its symbol is Pu, its atomic number 94. Its atomic weight is 244.06. Its color is silver white. Its standard state is solid at 25 degrees Celsius or 77 degrees Fahrenheit. Its classification is metallic. Unlike that Disney dog, life ain't no cartoon for me. I'm deadly serious. Made by nuclear scientists, a lump of me radiates heat because I release masses of radioactive alpha particles. In August of 1945, a nuclear bomb made from my 239 isotope was dropped on Nagasaki in Japan. It killed or injured close to 200,000 people. Plutonium's date of discovery or date of creation was in 1940. Its density is 19.816 grams per centimeters cubed. Its melting point is 639.4 degrees Celsius or 1,182.9 degrees Fahrenheit. Its melting point is 3,230 degrees Celsius or 5,846 degrees Fahrenheit. Here we have a map of 1940. Plutonium's date of discovery / creation. Plutonium, appearance, a radioactive silvery metal. Uses. Plutonium was used in several of the first atomic bombs, and is still used in nuclear weapons. The complete detonation of a kilogram of plutonium produces an explosion equivalent to over 10,000 tons of chemical explosive. Plutonium is also a key material in the development of nuclear power. It has been used as a source of energy on space missions, such as the Mars Curiosity rover and the New Horizons spacecraft on its way to Pluto. New Horizons was launched in 2006, and Curiosity rover was launched in 2011, January and November, respectively. Plutonium-4 oxide. Chemical compound. Plutonium-4 oxide, or plutonia, is a chemical compound with the formula PuO2. This high melting point solid is a principal compound of plutonium. It can vary in color from yellow to olive green depending on the particle size, temperature, and method of production, according to Wikipedia. Its density is 11.5 grams per centimeters cubed. Its formula is PuO2. Its molar mass is 276 grams per mole. Its boiling point is 5,072 degrees Fahrenheit, or 2,800 degrees Celsius. Its ChemSpider ID is 10617-028. Its appearance is dark yellow crystals. Its crystal structure is fluorite cubic CF12. Plutonium-4 oxide. PuO2. Plutonium-239 formation. Uranium-238 struck by a neutron creates uranium-239. It emits an electron after 23 minutes and becomes Neptunium-239. And then after 2 to 3 days, Neptunium-239 emits another electron to become Plutonium-239. The Uranium-239 and the Neptunium-239 are incredibly radioactive during the time period in which they turn into plutonium. Plutonium and all elements of higher atomic number are radiological poisons because of their high rate of alpha emission and their specific absorption in bone marrow. The maximum amount of plutonium-239 that can be indefinitely maintained in an adult without significant injury is 0.008 microcurie, equal to 0.13 microgram. 1 microgram is equal to 10 to the power of -6 gram. Longer-lived isotopes, plutonium-242 and plutonium-244, are valuable in chemical and metallurgical research. Plutonium-238 is an alpha-emitting isotope that emits a negligible amount of gamma rays. It can be manufactured to harness its heat of radioactive decay to operate thermoelectric and thermoionic devices that are small, lightweight, and long-lived. The half-life of plutonium-238 is 87.7 years. The power produced from plutonium-238 alpha decay, approximately 0.5 watt per gram, has been used to provide spacecraft electrical power, radioisotope thermoelectric generators, RTGs, and to provide heat for batteries in spacecraft, again such as in the Curiosity rover. Radioisotope thermoelectric generator. A radioisotope thermoelectric generator, sometimes referred to as a radioisotope power system, is a type of nuclear battery that uses an array of thermocouples to convert the heat released by the decay of a suitable radioactive material into electricity by the Seebeck effect, according to Wikipedia. Its fuel is plutonium-238. Here we have plutonium-238. Again, its half-life is 87.7 years. NASA.gov. It means every 87.7 years, there would be half of it. If you had 1 pound of plutonium, you would have 0.5 pounds. Half a pound. And then triple its half-life, you would have quarter of that. So again, plutonium can be manufactured to harness electricity and heat, specifically from its heat to generate electricity using the thermoelectric effect. In this case, it's called the Seebeck effect. Remember, you can make electricity using heat, or you can make heat using electricity. An example of heat used to make electricity, a radioisotope thermoelectric generator. An example of electricity used to make heat, think of any heater that runs on electricity, or think of a toaster. What happens if you touch raw plutonium? There is no health hazard from touching plutonium. Just wash your hands afterward so that any traces of it don't accidentally get inside you. It presents zero risk outside of the body. Plutonium is only a hazard if it gets inside you in large quantities, inhaled, ingested, or absorbed. Still, I wouldn't risk it. According to www.quora.com, what would happen if I touch plutonium? Quora. What happens if a human eats plutonium? You may develop cancer depending on how much plutonium is in your body and for how long it remains in your body. The types of cancers you would most likely develop are cancers of the lung, bones, and liver. According to www.atsdr.cdc.gov, Tox Profiles, Plutonium, Agency for Toxic Substances and Disease Registry. Why is plutonium so radioactive? Plutonium predominantly emits alpha particles, a type of radiation that is easily stopped and has a short range. It also emits neutrons, beta particles, and gamma rays. It is considered toxic, in part because if it were to be inhaled, it could deposit in the lungs and eventually cause damage. According to www.nrc.gov, Dot Collections Fact Sheets. Backgrounder on plutonium, nrc.gov. Plutonium-238 powers the Cassini spacecraft orbiting Saturn. Again, because it emits alpha particles, 2 protons and a neutron, plutonium is the most dangerous when inhaled. When plutonium particles are inhaled, they lodge in the lung tissue. The alpha particles can kill lung cells, which causes scarring of the lungs, leading to further lung disease and cancer. According to www.cdc.gov, Radiation Emergencies Isotopes. Plutonium-239, Pu-239, Radiation Emergencies, CDC. Is it okay to touch plutonium? Plutonium is, in fact, a metal very like uranium. If you hold it in your hand, and I've held tons of it in my hand, a pound or 2 at a time, it's heavy like lead. It's toxic like lead or arsenic, but not much more so. According to www.pbs.org, Pages shows reaction etc. Facts. Frequently asked questions. Nuclear reaction frontline PBS. Let's continue with element number 94. Plutonium was first made in December of 1940 at Berkeley, California by Glenn Seaborg, Arthur Wall, Joseph Kennedy, and Edwin McMillan. They produced it by bombarding uranium-238 with deuterium nuclei, alpha particles. This first produced Neptunium-238 with a half-life of 2 days, and this decayed by beta emission to form element number 94, plutonium. Within a couple of months, element 94 had been conclusively identified and its basic chemistry shown to be like that of uranium. Plutonium, heavier uranium. To begin with, the amounts of plutonium produced were invisible to the eye, but by August of 1942, there was enough to see and weigh, albeit only 3 millionths of a gram. However, by 1945, the Americans had several kilograms, and enough plutonium to make 3 atomic bombs, one of which exploded over Nagasaki in August 1945. Again, as previously mentioned, Nagasaki is a Japanese city on the northwest coast of the island of Kyushu. It is set on a large natural harbor, with buildings on the terraces of surrounding hills. It is synonymous with a key moment during World War II, after suffering an Allied nuclear attack in August 1945. The event is memorialized at the city's Atomic Bomb Museum and Peace Park, according to Google. The element was first detected in 1941 as the isotope plutonium-238 by American chemists Glenn T. Seaborg, Joseph W. Kennedy, and Arthur C. Wall, who produced it by deuteron bombardment of uranium-238 in the 152-centimeter, 60-inch cyclotron at Berkeley, California. Edwin Madison McMillan was an American physicist credited with being the first ever to produce a transuranium element, neptunium. For this, he shared the 1951 Nobel Prize in Chemistry with Glenn Seaborg, according to Wikipedia. He discovered plutonium and neptunium. Glenn Theodore Seaborg, again previously mentioned, was an American chemist whose involvement in the synthesis, discovery, and investigation of 10 transuranium elements earned him a share of the 1951 Nobel Prize in Chemistry, according to Wikipedia. He discovered plutonium, americium, einsteinium, curium, californium, nobelium, berkelium, mendelevium, and fermium. I previously talked about americium, einsteinium, curium, californium, nobelium, berkelium, mendelevium, and fermium, if you're interested in learning about those elements. Joseph W. Kennedy, American chemist. Joseph William Kennedy was an American chemist who was a co-discoverer of plutonium along with Glenn T. Seaborg, Edwin McMillan, and Arthur Wall, according to Wikipedia. He discovered plutonium. Arthur Wall, American chemist. Arthur Charles Wall was an American chemist who, as a doctoral student of Glenn T. Seaborg at the University of California, Berkeley, first isolated plutonium in February of 1941. He was a worker on the Manhattan Project in Los Alamos until 1946, when he joined Washington University in St. Louis, according to Wikipedia. Also discovered plutonium. Again, Berkeley is a city in Northern California on the east side of San Francisco Bay. It's home to the University of California, Berkeley, birthplace of the 1960s free speech movement. The 1914 Sather Tower, known as Campanile, has views of the campus and the bay. The open-air Hearst Greek Theater stages major concerts. Clustered on and near Telegraph Avenue, south of the university, are cafes, shops, and music stores, according to Google. And this is the location where plutonium was first created, Berkeley. The element was named after the then planet Pluto. Traces of plutonium have subsequently been found in uranium ores, where it is not primeval, but naturally produced by neutron irradiation. Neutron irradiation plus beta decay electrons creates eventual plutonium-239. And again, plutonium was one of the first radioactive elements to be visible in real life. In this case, the naked eye means unassisted vision without a telescope, microscope, or other device. You can see it just like that. Just like you can see anything else in your environment. Plutonium, Pu, radioactive chemical element of the actinoid series of the periodic table, atomic number 94. It is the most important transuranium element because of its use as fuel in certain types of nuclear reactors and as an ingredient in nuclear weapons. Plutonium is a silvery metal that takes on a yellow tarnish in air. Here we have an image of a figure with multiple arms. The image is inspired by Robert Oppenheimer's quote, following the first atomic bomb test in the Nevada desert. We knew the world would not be the same. A few people laughed, a few people cried. Most people were silent. I remembered the line from the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that he should do his duty, and to impress him, takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds." I suppose we all thought that one way or another. Plutonium has no known biological role. It is extremely toxic due to its radioactivity, as previously mentioned. Natural abundance. The greatest source of plutonium is the irradiation of uranium in nuclear reactors. This produces the isotope plutonium-239, which has a half-life of 24,400 years. Year 0, you have 1 pound of plutonium. Year 24,000, give or take, around 24,000 years, you have half pound of plutonium. Another 24,000 years, give or take, you have a quarter pound of plutonium. Plutonium metal is made by reducing plutonium tetrafluoride, PuF4, with calcium to create plutonium metal and calcium fluoride. Calcium fluoride is the inorganic compound of the elements calcium and fluorine with the formula CaF2. It is a white insoluble solid. It occurs as the mineral fluorite, which is often deeply colored owing to impurities, according to Wikipedia. Calcium fluoride, CaF2. IUPAC ID, calcium difluoride. Molar mass, 78.07 grams per mole. Density, 3.18 grams per centimeters cubed. Boiling point, 4,591 degrees Fahrenheit, or 2,533 degrees Celsius. Its melting point is 2,584 degrees Fahrenheit, or 1,418 degrees Celsius. Its ChemSpider ID is 23019. And here we have plutonium tetrafluoride. Plutonium 4 fluoride is a chemical compound with the formula PuF4. It is a brown solid but can appear a variety of colors depending on the grain size, purity, moisture content, lighting, and presence of contaminants, according to Wikipedia. Its molar mass is 320 grams per mole. Its formula, again, is PuF4. Its density is 7.1 grams per centimeter squared. Its melting point is 1,881 degrees Fahrenheit, or 1,027 degrees Celsius. Its crystal structure is monoclinic, or MS60. Plutonium tetrafluoride, PuF4. All plutonium isotopes are radioactive. The most important is plutonium-239 because it is fissionable, has a relatively long half-life, 24,110 years, and can be readily produced in large quantities in breeder reactors by neutron irradiation of plentiful but non-fissile uranium-238. So the non-fissile uranium-238 that originally has no use for bombs can actually be used to create plutonium, which does have a use for bombs. Step right up, folks. Make useless uranium into useful plutonium. Just add neutrons. Critical mass, the amount that will spontaneously explode when brought together, must be considered when handling quantities in excess of 300 grams, or 2/3 of a pound. The critical mass of plutonium-239 is only about 1/3 that of uranium-235. Uranium-238 has no critical mass, which means that no amount of uranium-238 that you can pile up together will create a critical mass. Does uranium-238 have a critical mass? Because depleted uranium has no critical mass, it can be added to thermonuclear bombs in almost unlimited quantity. The Soviet Union's test of the Tsar Bomba in 1961 produced only 50 megatons of explosive power, over 90% of which came from fusion because the U-238 final stage had been replaced with lead, according to Wikipedia. Wiki uranium-238. Uranium-238 Wikipedia. Critical mass. In nuclear engineering, a critical mass is the smallest amount of fissile material needed for a sustained nuclear chain reaction. The critical mass of a fissionable material depends upon its nuclear properties, density, shape, enrichment, purity, temperature, and surroundings, according to Wikipedia. The critical mass of a bare sphere of uranium-235 at normal density is approximately 47 kilograms or 104 pounds. For plutonium-239, critical mass is approximately 10 kilograms or 22 pounds, according to www.britannica.com. Technology, nuclear weapon. Principles of atomic fission, weapons. Britannica. So again, here's critical mass explained. For sufficient neutrons from the fission reaction to go on to create further reactions, then you need a certain mass of material. This is because some neutrons are absorbed by other atoms present and some escape from the material. The minimum mass needed is called the critical mass. Plutonium exhibits 6 forms differing in crystal structure and density. Allotropes. The alpha form exists at room temperature. It has the highest electrical resistivity of any metallic element, 145 microohm centimeters. An ohm is a unit of resistivity. Chemically reactive, it dissolves in acids and can exist in 4 oxidation states as ions of characteristic color in aqueous solution. Pu3+, blue lavender, Pu4+, yellow brown, PuO2+, pink, PuO2+, yellow or pink orange, and Pu7+, green. Very many compounds of plutonium have been prepared, often starting from the dioxide PuO2, the first compound of any synthetic element to be separated in pure form and in weighable amounts, 1942. So here we have uranium versus plutonium. Plutonium fuel. Plutonium-239 is primarily used as a fuel to power nuclear reactors. In fact, it enters into the composition of MOX fuel, mixed uranium and plutonium oxide. By combining the plutonium-239 produced by nuclear reactors with depleted uranium, MOX can be used to fabricate 1 new fuel assembly from every 8 used fuel assemblies. According to www.orano.group, Unpacking Nuclear, all about plutonium. Orano. Here plutonium's various isotopes and modes of decay. Alpha decay, spontaneous fission, alpha decay, spontaneous fission, alpha decay, spontaneous fission, beta decay, alpha decay, spontaneous fission, alpha decay, spontaneous fission, alpha decay, and spontaneous fission. And spontaneous fission is a form of radioactive decay that is found only in very heavy chemical elements, according to Wikipedia. So how's plutonium explained in the next minutes or less, in as a short amount of time as possible. Once again, if you liked this video, make sure to like, comment, subscribe. Other than that, thank you everyone for watching. Stay tuned for the rest of the videos on the periodic table. In the meantime, feel free to check out the previous videos that we've previously made on the elements and various other scientific topics. Once again, thank you everyone for watching. Have a great one.